Hello everyone and welcome to your Chem 113 review on the enthalpies of reactions in constant pressure systems. My name is Jason and I work for the ASU Tutoring Center. So what we have going on here is we have methane that is being combusted with oxygen gas to produce carbon dioxide and water. And this little thing over here, this delta H, tells us this is the enthalpy of the reaction. Enthalpy is a fancy term. Essentially, you can think of enthalpy as meaning heat energy. In the previous video, I discussed, there's various forms of energy. There's light energy, there's sound energy, there's heat energy. Heat plays a huge role in chemistry. And so we're going to focus on that today and during a couple of the other videos that we have. So what this says is that for every 1 mole of methane that reacts with every 2 moles of oxygen gas, we produce, to produce 1 mole of carbon dioxide and 2 moles of water. When this reaction takes place, we produce negative 890 kilojoules. So the negative out front tells us that we are releasing that energy, okay? So this reaction takes place, you say you have 1 mole of methane, you put it in a container, you have 1 mole of methane, you have 2 moles of oxygen gas, and you let that reaction take place, you let it do its thing. What it'll produce is you'll have 1 mole of carbon dioxide and 2 moles of water. And during this reaction, you're also going to produce some heat from your reaction vessel. Depending on how well insulated your reaction vessel is, it might not actually leave, but this reaction produces heat. And how much heat does it produce? It produces 890 kilojoules. So the negative sign out front just tells you whether it is being released or being input into the system. Because it's negative, it is being released by the system. So as this reaction takes place, it gives off heat. Okay, so as I mentioned earlier, I was very specific. This number represents how much heat is lost for every 1 mole of methane, or equivalently for every 2 moles of oxygen that are used, or every 1 mole of carbon dioxide that's produced, or every 2 moles of water that's produced. You can think about it in any of those 4 contexts. The one that we're going to focus on is methane, because we're told how much methane we have. So if we have 4.5 grams of methane, if we find how many moles that is, we can then determine the total amount of enthalpy of this reaction. So how we do this is we take the 4.50 grams of methane and we use the molar mass. So using the molar mass, 1 mole of methane corresponds to 16.05 grams of methane. So the grams of methane cancel out. And then this number here again, although it just says kilojoules, you can really think about it as being negative 890 kilojoules for every 1 mole of methane. And again, you can think about that in the context of any of the reactants or products you have. So you could also have equivalently negative 890 kilojoules for every 2 moles of oxygen, or negative 890 kilojoules for every 2 moles of water that's produced. All of these are equivalent, all of these work. We're just going to use the methane gas one because, well, we currently have moles of methane. So the moles of methane would cancel out. All you'll be left with is kilojoules. Doing the multiplication and division across gives us negative 250 kilojoules. So that is how much heat is released. So you would say 250 kilojoules is released, or you could just say the enthalpy of this reaction is negative 250 kilojoules. Those are equivalent statements. Okay. So that is our introduction to enthalpies of reactions. And we'll be discussing enthalpies and the different ways to calculate them in future videos as well. So thank you for joining me. As I mentioned, I work for the tutoring centers here on campus. If you want more information about the free tutoring resources we have on all 4 major ASU campuses and online, please check out tutoring.asu.edu/content/tutor-search. If you go here, you'll be able to find a tutor for your specific course on your specific campus or online. So thank you again for watching, and I hope you have a fantastic day.